So let's review what a database is based on the last lecture, since it's such a key concept. A database is simply software that organizes and holds information that runs on your computer, or a computer. Microsoft SQL Server is the relational database of focus for us in this series. The database will run on top of an operating system like Windows or Linux, both of which are supported by SQL Server as of 2017. Simply put, a database is a digital file cabinet or even a digital library. What I didn't mention before is that modern database systems, in addition to holding data, often provide a lot of additional functionality, like querying external servers, handling things like memory via the CLR with SQL Server, space allocation, and a lot of other things that I won't get into. In order to access the information in the database, we use a DBMS, or Database Management System, which exposes databases functionality through exposed interfaces that we can interact with. An analogy to a DBMS is a vending machine, in which you'd press buttons of the vending machine to choose the food you wanted. The vending machine's buttons would be the DBMS, and the data would be the food. The next layer, as depicted in the diagram that we are viewing, would be our application. The application will make calls to the DBMS in order to give us access to the database in a way we can understand, because interacting directly with the DBMS could be a little bit too complicated, confusing, and time-consuming for the average person. An example of an application would be Amazon's e-commerce website, our file browser, Windows Explorer if you're using Windows, Google search engine, or even SQL Server Management Studios. The application is what people usually interact with. Relational databases are simply databases that store data in objects that are called tables. These tables are often associated with other tables, and these relations are defined via objects called keys. So keys and tables are the defining objects of a relational databases. There exist non-relational databases that do not use tables or define relations. All database transactions adhere to the following 4 rules, also known as the ACID properties. This stands for atomicity, consistency, isolation, and durability. As you know or should know already, a transaction in database is a unit of execution. Atomicity ensures that this unit of execution will either occur or won't occur at all, thus preventing partial executions. Consistency ensures that after the transaction executes, it'll go from one valid state to another valid state. Isolation ensures concurrent execution of the transaction, so they will always execute in the order they were expected to execute, that they were meant to execute in. And durability means that the data will remain the same once the transaction has been committed, regardless of issues that may occur in the aftermath. SQL Server, the database suite we are learning, uses a database query language called Transact Structured Query Language, or for short, T-SQL. Different databases use a different dialect of SQL. Knowing the specifics of that particular dialect will help you to do more with less. As you write scripts and implement business rules and business functionality in the database. In SQL, there are 4 main data manipulation language operations, also known as the CRUD operations, that exist. For creating new data, we have the insert operation. For reading data, we have the select operation. For updating data, we have the update operation. And for the deleting data, we have the delete operation in SQL. These are also known as the data manipulation language in SQL, or DML operations. In SQL, just like the DML operations, there exists another group of operations called the DDL operations, also known as the data definition language operations. These include operations such as create table, drop table, alter table, rename, and various other operations that actually alter the structure of the objects in the database. So in summary, DML operations manipulate data, and DDL operations manipulate the structure of the objects in the database. I've been throwing around the word database objects, but I haven't been really clear as to what a database object was. I figured I would give you a few examples because I remembered it confused me a lot when I first started learning about databases. Some examples of databases include, but are not limited to, tables, views, stored procedures, user-defined functions, triggers, cursors, keys, indexes, synonyms, assemblies, link servers, full-text indexes, users, and roles. Basically anything in SQL Server that has a visual representation of it is an object. But as you work with SQL Server more, you'll get more of a feel for it. That's all for now. Get ready for some more fun stuff in the next lecture.